Okay. Um, so I have a 10-inch f 4.8 Newtonian. So that's 48 inches. It's a big thing. And I built it. It was one of these Astley scopes that we used to get together and build. And it's a great telescope for looking at things. And it has, I think it's a 1200 millimeter focal length, which won't really mean anything, but it's 48 inches long and heavy and all that. And I was using that for 4 or 5 years, I think it was. And a friend of mine in Ohio had made some connections with somebody in Australia by helping him out. And he and his brother-in-law went to Australia, and they were open arms by the Aussies. And so a couple of years later, he decided to put together this group and said, who wants to go to Australia? And I said, me. So I realized my daughter was graduating from college, my younger daughter, and I couldn't go with the regular group. So I went a week earlier, and I was going to go to the Outback, and I wanted to observe, and I didn't have a telescope. So I designed this telescope. It's a 6-inch mirror and f4. So it's about that long, and it's on an open board, and it doesn't even look like a telescope. But it's called a richest field telescope, and the focal length is 600 millimeters. Remember, my 10-inch is 1200 millimeters. A lot of Schmidt-Cassegrains are 1000 millimeter, or an 8-inch will be 2000 millimeters. So they're kind of like telephoto telescopes. And I was making a wide angle telescope, and they have a name for these things. They're called richest field telescopes because they're kind of wide angle. They take a much larger part of the sky. They're not, you could use them for planets, but it's better for just wide views of everything. So I went to Australia. It was astounding. I came home and I had this thing, and then I put it instead of being on a board. I should give a talk about it sometime. I did get a second prize in mechanical design at Stellafane for my telescope on a board, but then I put it in a regular tube, and I'll show you a picture of it tonight. So I came back, and I remember using it on Australia. I've got it finished just before I left. And this wide angle telescope, I got back, and it was like July, and I went out to Custer Institute, and I was looking at the summer Milky Way with medium power. It was like a 13 millimeter Nagler. And I started up, normally it's like you're looking at an area that big, and I was looking at a much larger area, and I was just scanning up the Milky Way that I'd never really done before, or I've done it with a higher power telescope. But with this wide angle scope, it was like a river of stars. And as you slowly, it's mechanical, as you slowly go up, there are knots and twisty things and white things and clouds of things. And I remember being stunned at how cool this telescope was for looking at the summer Milky Way. And I wasn't even that interested in looking at the individual objects. I mean, some of them, which I'll talk about tonight, I did. But for the next 6 months, that was the only telescope I used, because it was a whole new way to look at the sky as a wide angle telescope. And I'll never forget, for me, it wasn't finding those individual objects. It was going up this river of stars and watching all this stuff just go streaming through the eyepiece. And, for me, that made the summer Milky Way my favorite thing of all time to look at. And so that's where this talk is coming from. And it's not so much about the objects that you'll see, although since I'm a crazy person, I came up with 23 of the objects with brief descriptions, which I'll tell you about, and then I'll probably post it on the Astley mailing list. But so this talk is about sort of the experience of seeing the Milky Way. There's a disclaimer here. Why am I telling everyone here about how brilliant this is, but only if you're under dark skies? Like, it's not quite the same experience if you try and do it from your backyard. But when I go to Stellafane in Vermont, or maybe out to the East End to Orient Point, it's a really dark sky, and that's when everything is magnificent. If you try it under less than dark skies, it's like, you know. So I'm going to sort of give you the essence of the talk here, and then I'm going to show you some stuff. This is from Richard Berry's Discover the Stars. I'll show you the book. He was the editor of Astronomy magazine, brilliant guy. And he also writes poetically. And for me, when I look at the stars, it's about the poetic part. Like a mighty river, the Milky Way flows from the zenith through Aquila, Scutum, Sagittarius, over the tail of Scorpius, and into the southern horizon. No other region of the sky is so filled with magnificent objects for the naked eye, binocular, and telescope as the Milky Way in Sagittarius and Scorpius. On a clear, dark, moonless night, sweep this region with low power and marvel at the glittering fields that pass before your eyes. The star clouds of the Milky Way are most apparent with no optical aid at all. The great Sagittarius star cloud lies just east of Gamma like a celestial steam coming from the spout of the Sagittarius teapot, asterism. And once you see the teapot and under dark skies, it looks exactly like steam coming out of the teapot. It's about this great Sagittarius star cloud is about 7 degrees long and 4 degrees wide. A little farther north, enveloping the open cluster M24, is the small Sagittarius star cloud, roughly 2 by 3 degrees. The Lagoon Nebula, M8, is a faint patch to the naked eye, a twinkle of stars enmeshed in a glow through binoculars, and a magnificent star cluster floating in a glowing cloud with a telescope. This great mass of gas gave birth to the star cluster in it. A little north of the lagoon is the Trifid Nebula, M20, split into 3 by overlying lanes of dark material. Farther north, you'll find the bright checkmark-shaped Omega Nebula, M17, as a glow in your telescope's finder and a curdled glowing mass in the eyepiece of the telescope. The Milky Way is studded with open cluster. The brightest is M25, excuse me, a cluster of a few dozen, let's see, and then it's also full of globular clusters. But I think that gives you the sense that it's about the whole of it, not so much the individual objects. I'm going to turn the lights down so we can see the screen better. So I'm going to talk about the summer Milky Way, but I'm also going to talk about the telescopes I used, and I'll show you that Richest Field telescope. And I'm also going to talk to you about how I look at some of these objects, like the Lagoon and Trifid and the Omega Nebula and some of the others, the gaseous nebula. And I have sort of a complex process for looking at them all, and I'll touch on that. So this is the summer Milky Way. It's actually from out east. And what's really interesting is this little part. It's kind of a signature. After a while, once you've seen that, you start seeing it, you know, whenever you see a photograph like that. But isn't that magnificent? I mean, just look. I wonder if I can find, oh, so here's the asterism of the teapot. Here's the spout. That's the top. Here's the handle. and there's the bottom of it, and this triangle is the spout, and there's the steam coming out. So that's what we're talking about. And this isn't necessarily from the darkest of skies. Because I have looked at this before so much, I start out, the Messier 7 is a star cluster below the teapot. It's actually in Scorpius. But when I'm thinking 7 and 6 are magnificent open clusters, and then 8 is the Trifidite, the lagoon, and then 20 is the Trifid. So I start this incantation, 7 and 6 and 8 and 20, and I'm marching up into the, thus begins my climb up the Milky Way from the horizon. And here's the disclaimer, just so I don't get sued.
I don't want to see you.
What's that?
I don't want to see you.
Yeah, right. No, I'm going to use you as my defense attorney. So the equipment. So this is the 6-inch f4, and it's on, it's something I built, and it's on a tripod that I built. And this is it a little bit closer. It's not a big telescope. That tube is only about that long, so it's nice and light, and the wide angle views are just wonderful. And the other telescope I used for a little more detailed work, this is an 8-inch f4. I'm probably going to talk myself into a hole here, but if you're curious about the difference between a 6-inch telescope and how much light it gathers and an 8-inch telescope, the area of something is pi times the radius squared. I'm not going to get any more complex than that. So what we're going to do is square the radius. So the radius of the 6-inch is 3. So 3 3s are 9. That's just a number, but it's radius squared. The 8-inch, 4-inch radius, 4 4s are 16. You following this, Neil? Yeah. This is a program. Neil's a programmer and all the rest of it. I'm sorry. So 4 4s are 16. So this area has a number 9, the 6-inch, and the 8-inch has almost twice the area to gather light. So it's a huge difference in terms of both how much light you can gather and also the acuity, how fine the detail can be. So this is like my new favorite telescope because it's so lightweight. It's much lighter than my 10-inch f4.8, which sits on the ground. But for the talk tonight, I'll be talking about the 6-inch telescope. So eyepieces. Over the years, I would save up my money, and I would ended up buying Nagler eyepieces. So this is a 24 panoptic, which is a wide field. And when you look in the eyepiece, you see like 68 degrees of field. Plossl is 52 degrees. And the panoptic is a wide field, so it's 68 degrees. And then next to it are 2 Nagler eyepieces, and you see 89 degrees. So it's like when Al Nagler designed it, he said he wanted it to look like a porthole into space. And so Naglers are wonderful. The bad news is, I think the panoptic is 385, and each of the Naglers is 325. But I started buying them one by one years ago. So now I have, my happy place set of Naglers. So this is mainly what I use, and this is kind of basic, but in terms of picking eyepieces, the 24 millimeter panoptic wide angle is sort of my finder. It's a wide field, low power eyepiece for finding things. And to make it simple, the next eyepiece is 13 millimeters, and that's half. So that's twice the power. And the 7 is half of the 13, and that's twice the power. And I know some people have these complicated spreadsheets about which eyepiece you need for which object. But for me, it's I start with the wide angle, I double the power again, easy peasy. But to be truthful, and this is what I use for the Milky Way, but and this shows you the power that I'm using. To calculate the power, the focal length is 610 millimeter, and then you divide the focal length by the focal length of the eyepiece. So 610 divided by 24, I hope is by 24 millimeters, 25. So these are relatively low power. I mean, I think most people think, well, telescopes, you use them at 300 and 400 power. But in this case, 25 power, 47 and 87. And that's for most of the work that I do with the Milky Way. But in the interest of truth, it occurred to me I would show you the 5 millimeter eyepiece, another $325. And sometimes I want to look at a planetary image if the planets are up, or why can't I think of it? Planetary nebula. Yes, thank you. So then the 5 comes in handy, but basically it's 3 eyepieces. And that gives 122 power. If I'm using the other telescopes and I'm looking at planets, their longer focal length, I'm probably going to be at 200 power or more to look at the planets. So I feel guilty. Here's $1,200 worth of eyepieces, and you say, hey, thanks a lot. This is really helpful to me. I'll, drain my checking account. So I'm on this kick where I've been buying less expensive eyepieces from China or from Amazon. And so here are the bargain eyepieces. The 2 newest ones are the one on the left, the Astrotech 25 millimeter. And remember, I told you that the panoptic was 68 degrees. It was a wide field. So this 25 millimeter is 65 degrees. So it's pretty wide. And the 15 millimeter is Svaboni, and that's only $40. And that's not a bad eyepiece. I mean, if you consider the alternative is 300 and something, a $40 eyepiece. So I'm going from 25 millimeter, then 15 millimeter, which I'm a little loose with the math, is half. And then there's an Astrotech 5.5, and that's 60 degrees. And they're $40, and they're really good. I built another mount, and I want to be able to put a 3-inch refractor in my backpack and take it with me on the airplane carry-on, and I need lightweight eyepieces. Those Naglers are heavy. So that's one reason for doing this. And one other thing, there's a Meade 32 millimeter super Plössl, and that's 52 degrees. So it's kind of a constricted view, but it's also a long focal length, so lower power, a little more expensive at 65. So some numbers, the 24 millimeter panoptic used on this richest field telescope, the smaller one, the 24 panoptic on that shows 2.68 degrees actually of the sky, which is really a wide, that's 1, 2, 3, 4, almost 6 full moons. So for $365, you get to see almost 3 degrees of the sky. But if I go to these other ones, the 32 millimeter Plössl for $65, again in my scope, is 3.26 degrees. So it's wider than that really expensive eyepiece. And the 25 millimeter is 2.7 degrees. So that's the same as the panoptic for $40. There are differences, of course, but these are wonderful eyepieces. I'm really enjoying them. And it feels like I'm doing a public service, like, okay, if your telescope came with Plossl eyepieces, you know, how come they get sort of tedious to look through because they're a restricted view? And hopefully Steve Bellavia has also been on this quest to buy inexpensive eyepieces. So I'm holding out hope that you don't have to go into your IRA in order to do astronomy. So we can talk about, if anybody wants to know about any of these, I'm happy to talk about them, loan them. In fact, I don't have the 32, that's not a 32 Plossl, it's a 40. I don't have the 32 because I have a bunch of eyepieces out on loan to people so they could try them. And I'd be happy to loan anybody some of these if they would like. Anyhow, one other thing in terms of viewing the nebulae in the Milky Way is a UHC, and I think that stands for ultra high contrast. And this is a Lumicon that I bought, I think, in 1989, and this is an astronomic filter. And what it does is it cuts out light pollution, but it also allows, I need to be corrected on this, maybe Joel, it allows the hydrogen line to pass through, right? So the hydrogen and oxygen, thank you. Just oxygen?
Hydrogen is too far to the.
Oh, it's too far to the right, yeah.
Far to the right for our eyes to see.
Yeah. So what this does is allow the oxygen lines to come through, and that's what a lot of these nebulae are made up of. So I think they run about $100, and it's amazing how different an object looks even under a dark sky. This makes the dark sky darker, but in reference to that, the clouds of oxygen are brighter, and it allows you to see it in a different way. So I'm a big fan of this book called the Messier Album. It's by two guys. I bought mine, and it was the first book I bought in 1989. And you can buy it, it's no longer published. You can buy it used for $10. I meant to bring it and I forgot. But what they did was, one of them was in California and one was in the eastern part of the United States. And one guy had a 12-inch Newtonian, and he photographed all the Messier objects. And the other guy had a 4-inch Unitron, and he did drawings of all the objects. And then they put all that in a book. Here's what it looks like in a picture. This what it looked like to the human eye. And it's a wonderful source. And then there's this book too, but and this is Discover the Stars, which is also by Richard Berry. It's my favorite beginner book, and I'm going to show you some charts from that. And then I later went to this book for some of the illustrations. So this is one of the maps in Richard Berry's Discover the Stars. And I just love the whimsical, look at the horizon. Instead of just drawing a black line, he's got cacti and trees and little outhouses with wires going into them. I mean, really, it's just lovely. So this is one of the charts, which I've split in two. Look at how many of these objects, the brightest core of the Milky Way is of course lighter. And I put red dots, I hope they're visible, on the objects that we're going to be looking at tonight. But it's more objects than you can shake a stick at. But I also want to come back to that it's about scanning the Milky Way rather than comparing the individual objects. But then, since I'm a crazy person, I'm giving you examples of every object that's in red. So that's the lower end of that map. And this is the upper end. I went as far as Cygnus. So in the close-up, there's M57 off to the right, M71, M27. I guess I didn't do 29 and 39. But so that's up through the rift of the Milky Way. So here's my observing strategy, and I can't explain this. So I go to Stellafane and I set up my scope, and let's say I go to the Lagoon or the Trifid Nebula, and I start with the low power eyepiece. In my case, the Panoptic, it's 25 power. And I find the object using my Telrad, and it's easier to find because I have almost a 3-degree field. And then I look at it and I try and see the shape of the object. I try and see if there's texture, are there dark areas in it? But I also get a sense of where it is, a sense of place, what's around it. Are there other things in the field that are near it? And when I've done that and have a sense of the object, out comes the 24, in goes the 13 Nagler. Now, instead of 25 power, we're twice that, 47 power. And the Lagoon looks different. And I can't explain it to you, but I'm seeing different detail or more detail, or the shape is a little bit different or something, but it's different. I don't remember how I discovered this. People who've been observing for years would say, of course, dummy, everybody knows that. I didn't know that, but it changes its look in subtle ways. And I look at it for a while, and then most of these objects can still be seen. When I put the 7 Nagler in, I'm at 87 power, twice 47, and I have a 1-degree field. And a 1-degree field is enough to get most of these objects. And I see things in the 1-degree field at the higher power that I didn't see in the other powers. And I just find it's fascinating. I see more detail. I can't be specific, but it's just more interesting. It's fascinating how it changes as the power changes. So then I go back to the 24 Panoptic, but I put the UHC filter on it. Now, the UHC filter I'm only using for the gaseous nebulae. And there's, I think, 4 that come to mind: Lagoon, Trifid, 17 Omega, maybe 3. So now I do the same thing again, but with the UHC filter on it. And now it has more contrast, and I see some of the fainter wisps of the outer edges of some of these things because the filter is on it. And I spend time looking, and then out comes the 24, in goes the 13. I'm examining it again. I can see it in closer detail. I'm seeing more detail in the object, and it's getting a little darker because the power goes up. The background gets darker because of more magnification. And then I'll probably put the 7mm Nagler on and look at it again. So I'm probably spending 10 minutes or 15 minutes just on one object. But what's amazing is, if you do this, come see me when I'm on the hill at Stellafane, and I'll give you the tour with the 3 eyepieces and the filter and the whole rest. When you get done with that, it's like, wow, I've seen things here that I haven't seen before. I'm seeing more detail than I saw before. And so 10 or 15 minutes, but it's worth it. And then I'll probably start, actually up above that is the other one. And I'll do the same thing with the Trifid. Once again, 3 powers in white light, 3 powers with the filter. And when I'm done, I have a sense that I have really thoroughly observed that and seen that. And then that discussion probably works for some of the other objects like star clusters, and certainly for globulars. It's fun to see a globular as a little ball of stars at low power, and you can't resolve much of it. And then you go to a higher power and you start to see some outliers, as if you've sprinkled coarse salt on black velvet. And then you go to the higher power and you're seeing more of the salt grains, more of the stars in the outer things. And I don't bother to use the UHC filter because it's not a gaseous object. So I just find, as long as I'm going to observe, I like doing it with the 3 different eyepieces. And probably with star clusters, I can switch all the 3 eyepieces within a couple of minutes because they don't dramatically change the way the nebulae do. So that's my crackpot theory. So here are the objects, and I first copied the photographs in the Messier album, but the problem is they're high contrast. You know, that's a black field and bright things, and if they're nebula, they're kind of burnt. If they're nebulae, they're kind of burned out. And I thought that was unacceptable. So I went to this book, which is called the Messier album, and there are drawings rather than photographs. And of course, they're negative instead of positive, but there's more subtlety in the drawings, as you'll see when we get away from the open clusters. So anyhow, that's why I'm showing you drawings, and this is probably closer to what you're liable to see. I'll discuss these, and I'll try and go through them quickly. So M7 and M6, here's the 2 of them. 2 huge, bright, open star clusters, both naked eye objects. In a dark sky, you can see these faint glows down under the spout of the teapot. The brightest of their 100 or so stars shine at 6th magnitude. M7 is the larger and brighter of the 2. Oops. You know, I'm not going to try and point out where they are, but you saw them in the, I thought it would be too tedious to go back and forth between this and where they are. So these 3 globular clusters are inside the teapot along the bottom. And some of these are almost insignificant. I'll describe that to you when I get to them, but they're tiny and you can hardly see them. M54 is an 8th magnitude globular cluster, very small, little more than a fuzzball. And of course, this is seen with a fairly high-powered telescope for this book. And then M70, 8th magnitude globular cluster, very small fuzzball. So, like, it's not a great thing to see. It's not like, oh, wow, look at that. M69, 8th magnitude globular cluster, very small fuzzball. All 3 can be seen in binoculars, but they're going to be sort of faint glows. M62 is a globular, 7th magnitude, seems to be embedded in a background of Milky Way stars, very unsymmetrical, irregular around the periphery. So this is fun. I'll post this on the mailing list and you can print it out. And I'll tell you from the start, for some of these things, they're so faint, I've never really bothered to look at them carefully individually because some of them are really hard to find in the Milky Way. But this year when I go to Vermont, I have an Celestron Star Sense, and I made an adapter so I can put it on my telescope, the 8-inch telescope, and I'll be able to find each of these faint things individually, taking the easy way out, but by letting the Star Sense let me know where they are. So anyhow, M62, 7th magnitude, seems to be embedded in a background of Milky Way stars, very unsymmetrical, irregular around the periphery. It will be fun to look at that. M19, globular, 7th magnitude, oblate shaped. 7th magnitude is not all that bright, so these are not like wow objects. But then M22 is the brightest of Sagittarius's. Look at the difference in this between M19. Oh, and you'll notice underneath it says the field is 45 seconds. It's like half a degree, no, a little more than half a degree. So it gives you some scale. So M19, 7th magnitude. This is M22. The brightest of Sagittarius's many globular star cluster. And at 5th magnitude, it is one of the best and brightest in the whole sky. Many of you will know about M13 in Hercules, which is almost overhead in the summertime. This is not, it's down near the horizon where the teapot sits. But this is just magnificent to look at. And once again, look at the difference in size of it. And that's just an absolutely magnificent object. M28, globular, 7th magnitude. Okay, hope I do this right. M8, so this is where the drawing shows subtlety, that a photograph, all the bright areas that are dark here would be all burned out. The Lagoon Nebula is a faint patch to the naked eye, a twinkle of stars enmeshed in a glow through binoculars. So it's described 3 different ways. A faint patch to the naked eye, a twinkle of stars enmeshed in a glow through binoculars, and a magnificent star cluster floating in a glowing cloud with a telescope. This great mass of gas gave birth to the star cluster in it. This is the visual rival of M42, the Orion Nebula. It is a naked eye object under moderate seeing conditions. Excellent objects for small telescopes and binoculars. Most notable is the dark lane running through the nebula, which can be seen in telescopes of a 4-inch aperture or larger. You'll see the whole thing in a 3-inch telescope, but in a 4-inch, you'll start to see the dark lane, which of course is white here, going through it. M20, see the difference in size, is above it. M20, the Trifid, is one of the Sagittarius showplace objects along with the lagoon. The nebula is remarkable for its 3 prominent dark lanes converging in the center of its nebulous mass. I mean, these are knockouts, and 15 minutes each is well worth the time to observe them. M21, small, coarse, 6 8th magnitude stars with 55 other stars, but it's relatively tiny. M25, the Milky Way is studded with open clusters, and the brightest is M25, a cluster with a few dozen 7th and 8th magnitude stars. This is an interesting one. M24, inconspicuous, nearly lost among the stars of the small Sagittarius star cloud. So apparently there's some question whether the small Sagittarius star cloud, which you see more faintly around the darker center, whether that originally was the Messier object or whether it was the star cluster, which is now called NGC 6603, whether that was the object that Messier saw. So it's a curious object, and under the dark skies, you can see the brighter NGC object. And that may be, in fact, Messier 24, but I'm not sure. M23 is a yawn. It's hundreds of 9th and 10th magnitude stars, and 10th magnitude, you know, you need an optical aid to see them. So under, you know, with a larger telescope, that's probably pretty interesting. M18, tight and small, nearly inconspicuous, 12 stars. And this was found by Messier, of course. this is a cool one. It's gaseous. The bright check-marked shape Omega Nebula is a glow in your telescope's finder and a curdled glowing mass in the eyepiece of the telescope. It sort of looks, I'm probably doing this backwards, but it goes, it's almost like a 2 in some ways. They call it Omega and checkmark and all of that. But it's an object that you are rewarded if you spend time studying M17. M9 is a globular, 8th magnitude, quite small. It looks like a star in 750 binoculars, which is also a good point. It's rewarding to scan the Milky Way with binoculars. It's not as, you won't see as much detail as you will in my richest field scope, but it's certainly worthwhile to let the Milky Way scroll through the field of 750 binoculars or 840s or whatever. M16 is another gaseous nebulae. It's called the Eagle Nebula. And this is interesting. It is something. You see that it's a nebula, but I just learned this in putting this talk together. To see the eagle shape of the nebula, you need at least a 17-inch telescope. You will see a gaseous shape, but it never looked like an eagle to me. And I read that you need a telescope that has much larger light gathering power. But it's still a cool thing because this gaseous nebula and a star cluster. Some nebulosity can be seen in binoculars and richest field telescopes. M26, it's an open cluster, 8th magnitude, not very impressive because it's seen against the Milky Way background. So if you put 8th magnitude stars and all the fainter stars of the Milky Way, it sort of disappears into the background. M11, the wild duck cluster, that's a lovely thing to look at. It does not look like that here, but in the drawings in the Messier album, it's sort of like that. It's like a boomerang. It's a lovely object to look at with all, it's an open cluster that can be mistaken for a globular cluster in smaller telescopes. Best in moderate apertures, 6 or 8 inches, 10 inches. 500 stars, brighter than 14th magnitude. It's absolutely a lovely sight to see, and you can see it naked eye. M71 is a globular cluster. 8th magnitude immersed in Milky Way background. And the last one is M27, which is the Dumbbell Nebula. It's a nebula, gaseous, large and bright. This diaphanous object shows some color and detail in telescopes of moderate aperture, and it is easily visible in small scopes. It is one of the largest planetary nebulae and the first object of its kind discovered by Messier, July 1764. The end. Are there any questions? Thank you.
Ken, do you ever also try to experiment with Barlow's? There's not enough light for that.
I would use a Barlow on maybe a planetary. There was a thing in terms of ease of use, and I know this sounds like a crazy expense of money. My first 24 was a 2-inch, Nagler made it. It was a 2-inch eyepiece, and the 13 Nagler was 2-inch, 1.5 inches. It had a 2-part thing. And then the other Nagler was 1.25 inches. And so when I was observing, I would take the 1 1/4 inch adapter that looks like that with a hole in it. I take it out, put the 2-inch eyepiece in, the wide field. Then I'd go to the 13 Nagler, and then I'd have to take the Nagler out and put the donut back in, and then put the 7 Nagler in, and then observe with it. And then if I wanted to go back, I have to take the eyepiece out and the donut out, and then back to the other one. And I was thrilled when they came out with a 1 1/4 13 and an 1 1/4 24. This is, you're wondering where I'm going with this. And the answer is, it is so much easier. The eyepiece goes in, it comes out, in, out, in, out. And at one point, for a refractor that I bought 10 years ago, a 4-inch refractor, I was using the 5 Nagler and I wanted more power. So I put a Barlow in and then the 7 Nagler, and that stuck out about this far. And so I know this is wretched excess, and I thought about it and I thought, all right, I'm going to buy a 3.5 Nagler. So that means I could look with the 7 Nagler, take it out, the 5, take it out, 3.5, seamless. So yes, you can use a Barlow, and it's a good idea. It saves you money to use Barlows. I have them, but I don't use them now because in wretched excess, I bought one of every focal length. But the Barlow is good for that, and especially for planetary nebulae and for looking at the planets.
Yeah, I think the Barlows are mostly, like, I use my Barlow really only on days of really good seeing, when I'm trying to get the planet at the highest power I can get, because my lowest eyepiece won't go as high as, I want to get like that extra double power, my lowest eyepiece, smallest eyepiece,
Right.
on like a, not a good seeing with planets.
This is going to be hard to describe without a picture, but I have an eyepiece lecture. For those of you who own Plössl eyepieces, the eye lens that you put your eye up to is about 5/8 of an inch, maybe 3/4 of an inch in diameter. Maybe it's that big around. So there's plenty of room to put your eye up to it and move it all around. If you get a 12 Plössl, the eye lens opening is like that, and you can get your eye up to it, but your eye has to be closer to it. It doesn't have the eye relief. The eye relief is how high can your eye be above the eyepiece and still see the circle inside. So I didn't know this, and a lot of the scopes come with a 20 millimeter Plössl and then a 10 millimeter Plössl. And the difference is you have to put your eye right up to the 10 millimeter. So if you buy a 2x Nagler, 2x Nagler, if you take the Plössl, it will take a 26 millimeter, and you look at it and it has that eye lens in it, and you want to double that power, you take the eyepiece out, put the Barlow in, and put your 26 back in, and the Barlow halves that focal length to 13 millimeter. So now you have a 12 millimeter eyepiece, but it has the big eye lens because it's really a 26, and it has that eye relief that the 26 had. So if I had to go back to 1989, I would buy the 26 and a Barlow instead of a 26 and a 12. So that's the advantage of the Barlow, that you end up using longer focal length eyepieces, which have greater eye relief and a larger eye lens to look through. So it's really a bargain starting out. Any other? Well, thank you for your attention. Let me go turn up the lights.
Okay.
Yes,
Your thoughts on a zoom lens?
a zoom lens.
Is all those individual?
Steve asked about a zoom eyepiece. I have a Celestron 8-24 zoom which I use for my hydrogen alpha solar scope. And they work well for that. I'm just looking at the sun, and you look in there and you see all of it, and then you just twist this collar and it goes from 8 to 6, smoothly from 8 up to 24 3 times. And that's good for looking at the sun. Ed Anderson is a huge fan. What's the eyepiece that he loves? It's a Baader 8 to 24 zoom, and it's much bigger. It's a beautiful eyepiece, and I bought it. I'm not using it. I'm going to get around to it one of these days.
Use it, that's what I use today.
Okay. So, but here's the thing, that it's a zoom eyepiece, but I think its field of view is about 52, like a Plössl. Yeah. So, it's like when you put your eye up to it, like I'm doing here, I'm only seeing, it's like looking through, let's say a toilet paper tube. And if you use the Naglers or the wide field, I become spoiled. It's like taking a mailing tube like that and cutting it at the same length as a toilet paper tube. And do you want to look through this, or do you want to look through that? So I'm a little bit spoiled, but I think it's probably a really good choice for starting out, because you have all these different focal lengths. And the beauty of it is you just turn the knob, and the what is the Baader, about 300, something like that?
58 to 310.
I'm sorry?
$258 to $300.
Wow, that's a bargain.
I was looking at.
Yeah. If somebody wants to borrow it, or when we're observing, maybe I should bring it next time, and you could try it out. So that's really a bargain, because it smoothly goes between all of those focal lengths. It's a heavy eyepiece, so it's good for substantial telescopes. One of the minor problems I have is the scope that you've seen me use. It's a square plywood, sort of mahogany looking scope designed by Richard Berry. That I bring it to all the Moonwatch events, and I brought it to Astronomy Day and all that. It's a 6-inch f6. And because of the way I built it, the Baader zoom won't come into focus. I'd have to move the mirror up the tube in order for it to focus. So that would be the perfect thing for Moonwatch, because what I do is show people the moon with the 24 millimeter eyepiece, and then I say, okay, I'm going to put the 7 millimeter eyepiece, and then they see the craters in much better detail. But then if I move it, then the other eyepieces may not come into focus and all that. But that would be the perfect eyepiece for outreach, because you're not taking eyepieces in and out. You just turn the collar. But if somebody wants to see it, I'll be happy. Send me a note and I'll bring it to a meeting and you can try it. But Ed is a huge fan of that. So it's a good question. Thank you. Turn off recording. Thank you. I need a checklist for this.
Like an airplane.
Like an airplane. I'm overwhelmed with checklists. I'm back to. Oh, yeah, good. I wondered why the lady didn't talk to me.